I'm Troy Peterson. I'm an executive IT architect with IBM. Work in IBM systems with the Power Group. And I also have with me, I'm just going to introduce things, but the main speakers here, the speakers who are on the agenda here, we have Steve with the WebSphere Liberty Group, and Bruce also with Power Systems. And so the main topics are Liberty and TurboLamp and what we're doing with the NGINX. But given that we know a lot of times in these open source type conferences, there might be some folks that aren't familiar with what Power is. So I wanted to just give you a very brief overview of what Power is. And so we'll start out with just a quick overview of Power. So Power has been around for 25 years. It's a server platform. So most people know about, think about IBM. They think about the IBM mainframes from a hardware standpoint. Everyone knows that we have the IBM mainframe. So the Power is another server platform. It's our mid-range server platform. Been around for 25 years again. We're on our 8th generation. So now we have the Power 8 processor. So IBM designs, develops their own flavor of processor. That is higher performance than the x86 processor. And so there's, of course, the increasing generations, we're, always, improving the performance of it. But actually between Power 7 and Power 8, there actually hasn't been any frequency increase in the processor. But we still have double performance because as we all know, Moore's laws, we're starting to see the effect of Moore's law, kind of trailing off. And so we're looking for other mechanisms to increase the performance of our processors, such as, increase the internal bandwidths. And, one of the real interesting things that we're doing is around acceleration. So one of the acceleration technologies we use is this CAPI, the Coherent Accelerated Processor Interface. So CAPI allows you to have very high performance interaction between components, between the processor and different components, such as flash memory. We can get flash memory, even external flash memory or flash memory cards to have RAM-like speeds going from the processor to that flash memory to enable you to have cheaper memory because flash is cheaper at near RAM performance. Also with partnership with networking cards, so we can have a high speed, have additional capabilities for performance for memory and other attachments to the processor. So another technology that we're coming out with that we'll be introducing with our Minsky servers later this year, which is a high performance servers, high performance computing servers, is NVLink. So it's not specific for high performance computing, but for any kind of GPU interaction. So it's a NVIDIA technology that we're partnering on that we're able to deal with increased bandwidth. So the GPU is the GPU, but where we shine now is using NVLink. We can have much faster, much higher bandwidth, much faster between the processor and the GPU, and also between the GPUs. So that helps to give us a lot of performance when we're using a GPU when we have a lot of bandwidth. And high performance computing is one use case of that. So the Power 8 is the current generation, but we're continuing to build out Power systems. We got the next generation, Power 9, is coming out the second half of next year. We've already announced that, and that we're shrinking down the die to 14 nanometers, and eventually, even with some partners, going down to 7 nanometers within the Power 9 timeframe, and we're also already designing Power 10. So Power 10 is not out till 2020, but we're already, starting to work on the design of that. So Power has been a player for over 25 years, and we're continuing to innovate to continue to increase the performance. So some of you who saw Kim Korner's presentation this morning already saw this in the next slide, but just to point out, why do we have so much better performance than x86? So one of the things is we have more threads per core, right? But that's actually configurable. We can go anywhere from one thread. So if you have say a batch application that that can't take advantage of multi-threaded architecture, you can go anywhere from 1, 2, 4 to 8 threads per core. So, but most of the scale-out architectures that we're dealing with today, so the multi-threading makes a big difference, and Bruce is going to show you an example of that. And then we also have, the increased memory bandwidth, but also the amount of memory. So the amount of memory we can have in our systems is also larger than x86, which makes a difference in some workloads. And then, of course, the cache, but also the I/O bandwidth is also higher. So we get benefits not only from the fast access to memory, but also fast access to I/O. So we have a whole range of power systems. So a lot of folks, they think of, the old days of power system. They think of these big, huge power systems, that, have, take up a half rack or full rack type systems. And we still have those. Those are our enterprise systems. But so this is just a portion of our portfolio. This is the part of the portfolio that's Linux focused. So on these big boxes, we have IFLs that allow you to run Linux on these large servers at a price point that is very competitive. We also have Pure Power, which is our converged infrastructure, and we have the L line, which gives us the same kind of RAS, reliability, availability, serviceability, as we have with our, AIX, our Unix and enterprise type systems. But we have firmware on there that will only allow you to run Linux on it, and then we sell that at a little bit, lower price point to make it more competitive. But it still has, very, very high reliability, enterprise grade reliability. But now we're finding, like in the cloud space, a lot of these, cloud providers and managed service providers, they don't particularly care about the reliability. They just have all these servers, and if one goes out, well, they just swap another one in, and they're not really concerned with it. They're really looking at TCA, that cost of acquisition. So now we have this LC line that doesn't have all the reliability that we do, so it's more competitive from a reliability standpoint, but it's at much lower price. So now we're priced very, very competitively against x86, but I still have that higher performance. So the price performance, against 86 at that is very, very compelling. But we also have power out there in the cloud, and from an IBM offering, we have soft layer, but we also have through partners we have available for other clouds. As well. So power is available out there as a cloud offering as well. And so IBM now has a very, very big Linux agenda, right? So we've supported Linux for many years, but over the past few years, we wanted, really in the past, we were really kind of focused on specific Linux workloads that are required by our enterprise clients that, that was kind of high in demand. But now we want to be a first-class Linux player. And so we realized we had a lot of work to do to really make Power be a first-class Linux player and to be, widely pervasive. And so we knew we weren't going to be able to do that alone. So we established an open Power, the Open Power Foundation, along with Google and some others, which we're now kind of open sourcing the Power platform. So we're making partnering with a lot of partners to be able to make Power to be able to have players in all levels. So all the way down to the chip. So we're going to actually have other makers other than IBM that are going to be offering Power chips. We have systems. We have Supermicro that's now making Power systems. We have Tyan. So we have multiple now hardware providers. So it's not only IBM selling Power; it's other offerings as well. And then system software and networking. So all layers of the stack, we have partners to make this ecosystem to really open up the Power platform. And from a development standpoint, so Power is a different chipset, different instruction set. It's RISC-based architecture, but it's still very compatible, with the x86. Interpreted language and scripting language, so like Java and PHPs, this one, so we run the same versions of Linux. So we have Red Hat, SUSE, Ubuntu, and also the community-supported distributions are all available on Power. And they're the same distributions, same capabilities coming out at the same time, but optimized for Power, of course. So it is a different build, different binary, but it is completely compatible, with the distributions that are running on x86. But what I was starting to say about in terms of the being able to move to Power, so an interpreted application like Java and Python, it'll just run on Power, or scripting applications like PHP and Perl, they just run on Power. You don't have to make any changes. You just deploy it to Power and it'll run. It'll just run better. But C applications, C++ applications, any compiled applications really just need to be compiled. And almost 95% of the applications out there, they just need to recompile. If you have applications out there that do, say, kind of say architecture-specific calls without doing an architecture check first, well, those are going to need to require a little bit of code modifications or drivers. So there are some things that will require some modifications, but for the most part, it's just a recompile and run. Okay, so now I'm going to turn it over to Steve, who's going to talk about the Liberty Docker deployment with NGINX.
All right, so let's talk about something maybe a little more familiar to some of you, and that's Docker. And so I don't want to assume, though, everyone knows what Docker is, so we'll start with a definition. Docker is an open source project to easily create lightweight, portable, self-sufficient containers from any application. And that's a definition you'll find all over the internet, probably originated with Docker themselves. I couldn't track it down, but that's the definition of what Docker is. And so when you talk about using Docker, really when you move to some form of containers, this is going to greatly reduce the amount of deployment time. And that's really one of the things you're after. So for example, Docker containers. So you start on the first column here, and it's talking about the amount of time to obtain a system to do your deployment. And obviously when it's bare metal, that can take days, to get a system. With the virtual machine, perhaps minutes to get a virtual machine lined up for yourself, and a container, seconds. And as you move to the right, you can see that containers are giving, really the shortest time to deployment, manual or automated, or staying lockstep with virtual machines. And depending on your environment, what you might want to use there, virtual machines versus containers. But when you do startup, when you actually start the container, that's when you're going to see a big benefit as well, because containers are going to start in seconds, and even a virtual machine may take up to a minute, to start that machine. IBM Research has done some analysis of Docker performance and found that Docker really performs near to bare metal. I mean, it's almost as good as having installed just on a system in the bare metal. And so I think that's a pretty impressive piece of information. And this evaluation was actually done on Ubuntu 13.10, 64-bit Linux, just for information. But again, Docker is going to give you that performance you need with your applications. So Docker and IBM. IBM is fully engaged in Docker. We're a member of the governance advisory board with Docker. We contribute on Docker projects. We have a strategic partnership with Docker. And we've also ported the Docker engine to Linux on Power, which we're showing as a demo here at the conference. And we've also ported the Docker engine to System Z, so you can use Docker in those environments. And you can see there's a number of other things that IBM is involved in with Docker. The last point there is we've also containerized a lot of IBM software. You can find it out on Docker Hub. And so you want to work with a piece of IBM software in Docker, we've already done that step of putting it into a container for you. So Docker on Power. Docker is even better on Power. You've just seen Troy's gone through the slides of the performance you get from Power, so it shouldn't be a surprise that with Docker we see those benefits too. You have greater system capacity to run typical cloud-native Docker workloads. You can have more containers per system on these higher-powered systems, which results in a lower cost of operations for you. And then Power excels at data-oriented workloads running in containers. And so the Power platform is built for this type of workload consolidation, and Docker really enables that. And you can literally run thousands of Docker containers on a single Power system, and we'll see more of that in a little bit. And then Docker tools are also available on Power. If you've worked with Docker very much, you're familiar with tools such as Swarm, Compose, and Docker Machine. Those are all available on Power. Kubernetes has also been tested and is available for use on Power. And Mesos is already runs on Power, and IBM Research is working with the community for some additional changes, improvements there. And then, so I mentioned already that you can run thousands of containers on a Power system. The IBM Research, one of the IBM Research teams has pushed the limits here, you might say, a bit, and they've created a 10,000 container environment on a single Power system. And that's quite a feat just in and of itself. And the initial container start time had an average startup of a half second. So that's kind of maybe what you would expect, to see that. But even the 10,000th container had an average start time of only 22 seconds. So I think that's very impressive, for 10,000 containers in one piece of hardware. And at the bottom of this slide, I have a link where you can read more about that environment they built and the things they did to tune and that sort of thing. So WebSphere and Docker. So WebSphere Application Server Liberty and WebSphere Application Server, the traditional WebSphere, are supported and running under Docker now. On Docker Hub, we have images available for development use of these. For instance, the latest Liberty driver came out in this summer, version 16.002, and that's available on Docker Hub. It has the kernel and the Java EE 6 and 7 web profiles, and we have the whole Java EE 7 profile as well. And then also WebSphere version 9. So traditional WebSphere version 9 is also available on Docker Hub, and that has full Java EE 7 support. And then additionally, we have on the WasDev GitHub. So WasDev is a website for WebSphere that is mainly focused on Liberty. So it has a lot of helps and tips and things out there. You can go out there and download Liberty and one click. You don't have to sign any licenses or anything like that. Just download and start using it immediately. And so on WasDev, we have Docker files for things like upgrading the Docker Hub image from that development use to a base or ND license. And also we have help out there to instruct you how to build your own Docker image for Liberty in whatever version you want. And I mentioned that the images on Docker Hub are for development use. That's just a licensing statement. There's nothing missing in these. It's the full product. It's just, all that licensing stuff. So that's why we say that, but it's the full product. So Liberty and Docker, and you may or may not know what WebSphere Liberty is. Let me define that a little bit. WebSphere Liberty is a dynamic and composable runtime allowing for lightweight, custom-fit Java application servers. So it's a Java application server. And because of its composable nature, it allows you to reduce the memory, the disk, and the startup time of the actual server. In fact, the startup time is generally less than 5 seconds. And the nice thing about the composable features is that you just configure whatever you want to run in your server. So maybe you don't need JEE 7, so you don't include that. Maybe all you need is the web profile, something like this. So it can be as lean as you need it to be. And the configuration of Liberty is simple. There's just one small configuration file. that does nice things like having reasonable defaults, so you don't have to configure everything. You just configure anything you want to change, essentially. The Liberty server also dynamically responds to configuration changes so that you can change your configuration. You don't have to restart the server. It's just immediately will process and run with those changes. And that makes it excellent for configuring inside of a running container. So you have your image, your Docker image, and then at runtime when you deploy it, by just touching a file in that container, you can reconfigure it to do whatever it is you need. And so this slide is showing some of the composable features, and actually showing all the features of Liberty, so it might be a little bit to try and take in 5 seconds. And you can see how you start at the bottom. That's the Liberty core, and that's a freely available version. And as you move up then to base and ND, etc., we're adding more composable features that are still consistent in their capability. So you start with Liberty Core. It has EE6 and EE7 web profile. You move up to WAS base, you get things like full EE7 support. And then once you move to ND, you get some of our large-scale cluster management software. For instance, the collective controller, so that you can set up clusters and build large topologies and manage them all through a few controller servers. With this environment, I think it was mentioned in the keynote earlier, we've built this environment up to 10,000 application servers being managed by one set of controllers. And so that's a pretty large set of application servers to have running in your enterprise. And then on top of that, we have WebSphere ZOS. Those are essentially features that exploit some of the features of the Z platform. And so that just give you an idea of the composable features of Liberty. And again, each is enabled just as required dynamically, so that you can have that fit-for-purpose server. You don't have any bloat in your server. And this is an example of the server configuration. I think actually the explanation of this configuration on this slide is more complicated than the actual configuration as you look at it. So this is a server XML file. It has just 2 features. It has JSP and JDBC. And so you just essentially this file can be very small and light like this if you don't really need to override any of the defaults. We also support within this configuration file using includes in the XML, so that maybe you have a configuration that you want on every single server. You could have that on a network drive or somewhere accessible, and just include it in all of your servers so that you don't have to repeat that configuration over and over, which is a nice thing. One last thing that we have that I'll mention is the config drop-ins directory that we've added in the Liberty server. And this is a directory on each server that allows you to simply drop new configuration XML into that folder, and then the server will dynamically process that and respond to it. So without even touching the server XML, you can just drop a new XML into this folder, and it will process that and be running with that configuration. And again, this is really useful with Docker, because you can have your kind of vanilla image that you use, that you push out, and then as you push it out, you push some configuration into that running Docker container, into the appropriate config drop-ins directory, and then boom, it's running on that configuration. So very easy to customize your environment. This diagram here is depicting the demo environment that we've been showing at our table. One of the demos we have. This is the demo that relates to Liberty. And what we have here is this is all on one power system. And on the left, we have a virtual machine that's running NGINX Plus. And NGINX Plus, then, that virtual machine has 1 core and 16 gigabytes of RAM. And it's running as the load balancer, receiving web requests, which are then dynamically routed to a set of Dockerized WebSphere Liberty servers hosting the application. And that's on another virtual machine on that same power system. It's a much larger virtual machine. It has 9 cores and 32 gigabytes of RAM. And for the demo, we just set it up with 100 Docker containers. No particular reason, just pick that number out of the air. And we didn't do any extra tuning to try and maximize the environment, but just pick that number at random. And so if you've come by, you can see how all the requests are being routed through those to those Docker containers. And this represents work on both the IBM side and on the NGINX side. The NGINX team, you may have seen a recent blog post of them adding support for Power in NGINX Plus. And so that's what this is showcasing. And then as well, this is showcasing that indeed you can run Docker on the Power system and then running Liberty inside of those Docker containers. And so that's what this demo is showing you, just for your information. All right, so let me pass it on then to Bruce.
Great. Thank you very much, Steve. Okay, so that was J2EE, and so now we're going to do the other technology we enabled was PHP applications. And as we mentioned, this just sort of about 2 or 3 weeks ago, we got the word that NGINX got this, their NGINX application available on top of Power, so this came up pretty quickly. Pretty much, I'm sure all of you know about LAMP stacks, and so the LAMP stacks are ubiquitous out there. If you've done inline shopping or you've run on a LAMP stack. So we got together, IBM did get together with some partners here on the right, and we built essentially a better LAMP stack, a turbo LAMP stack. So we had that running, and now the NGINX family has joined our family of turbo LAMP members, and so we utilize the NGINX as both the load balancer and the Apache, the app server then in our configuration. So again, I'm going to skip some of these here. So this is why run LAMP stacks on top of Power? It's more efficient. We get more work done. We can get more LAMP stacks, more users running on top of Power. We've got some releases coming out. We do have a community edition coming out of free software, using all community editions. But we are excited by the fact that the Rogue Wave open source is offering essentially a support contract for the whole solution stack. So you're just one belly button to poke. And so if you're considering using open source, we're pretty excited about that offering, combining essentially a solution support with all the open source software. And then we'll be working on an enterprise version of TurboLamp later this year. So how do you evaluate TurboLamp, different TurboLamps running on Power and running on x86? So it turns out the Magento team has a performance toolkit out there on GitHub that actually does a great job of evaluating LAMP stacks. It evaluates the app server, the network, and the database, and they've got a data set. It's always tough to find a good data set and a load generator, so they've got one out there. So we picked it up, and we set up a topology here on top. We've got 4 virtual machines running on one of our Power boxes, an Ubuntu KVM, 4 virtual machines, and then we set up essentially a similar topology on a 24-core Haswell box. So again, somewhat of a 2-tier, a load balancer, a small cluster of 2 app servers, and a data store in the back end. So physically, that looks like. So our system's under test are on the right again, the 24-core Haswell box with running the 4 virtual machines, and we've got essentially the same similar 4 virtual machines on top of the 16-core Power box, and the load generators are a completely separate box over there, off the network there. I mean, it's on the network, but it's not associated with those boxes. As far as creating VMs, just like you're used to doing on your x86 box, you do it the same way on top of Power. It's the same Linux, so you're running on top of Power, so all those same tools you're used to. There are some little things we noticed because a lot of these tools are developed on top of x86, so out of the box, they're tuned more for the x86 environment, so you do need to be a little careful when you drop them on top of Power, adjust some of the settings. In this case, the virtual networking, the Realtek NIC, wasn't tuned very well, so we did go ahead and switch that one out to an Open vSwitch. We do set up the VMs so they're sort of aligned with the NUMA. We're NUMA aware, so we know where the sockets are, the cores and the sockets are, so we set the VMs up so we're associating different VMs with specific cores, and this helps with the cache management, and we're using all local memory. We'll be able to send this deck out to anybody, but here are just some examples of how we do that association within the domain files in the VM, how you align the VMs with the cores. As far as NGINX configuration, Alan's back here was a great help. We got him a link into our lab, so he was a big help in getting both my setup and Steve's setup up and running. I think some of the big things we found, we did have to use a persistent cookie for the admin flows, was one of the big changes. The other one was down here on the load balancer on the left was to make sure we set the host variable and pass that through. Somewhat it depends about the way Magento operates. We did write it, didn't change this. This was using the Unix sockets. I ran into trouble with Unix sockets, and I don't see Cole here. Cole came up and pointed out their team had the same problem, so he's got a solution for us. So I did switch back over to network sockets, and that cleared up a bunch of issues. And the other key thing is we had to use the alias, the wildcard for the server name, again, because we were running in a cluster. As far as getting Magento, which is going to be our test application now, it's real easy. If you download it, you want to get the one without the sample data. They have a sample store, but you want the benchmark. We're going to put the benchmark data in later, so you want the one, pull the one without the sample data, pull that one down. You unpack it in your document root directory, and then you go to your URL/setup, and the installation will fire up. It's a very nice, straightforward. It does some readiness checks here. The PHP packages you need to make sure is on your system. It will make sure they're on there for you and won't let you proceed without it. And so again, you just sort of step through. You provide a database connection, provide a store address. Don't make it if you've got a cluster, don't make it the host name of your app server. Come up with a new virtual name, and you're going to set that name to the front door to the NGINX load balancer front door. Okay, so we finished with the install. We'll finish up less than about 2 minutes, a minute or so. Okay, so you're all set here. One little gotcha, don't go and set up the installation data right away. You've got to run the indexer first. And the indexer is very easy to run. It's a PHP command right there. So run that indexer first, then log into the Magento admin flow and flush the cache. And at this point, now you're ready to load the benchmark data. And again, it's a nice setup. The benchmark team, they've put out test data set. They've got 4 sizes, small, medium, large, and extra large. We use the medium right now for our testing. But again, it's a great, nice way to generate the data set. And then we're going to do this load, and it's a single command that you're going to execute, and it looks like it will report out. It runs about 10 or 15 minutes. It will take, because it's loading up all the JPEG images, it's setting up the data structures in the database, but it will report what it's doing as it moves through there. Once you get the store set up, if you actually go look at the store, it's not very sexy, it's very boring, but it is actually loaded. All those are all JPEG images, they're all the same, but as I said, it's a full test of networking. You'll pull down on, you can click through there to the different categories and imagine that you'll see all, you think you would see all shirts or pants or something, but you can see and navigate through it. But everything's there set up as a real store. Setting up, install Jmeter, you do need those additional 2 plugins to be installed so that you can, Jmeter will run. I do fire up the GUI with Jmeter and step through the flow to make sure all the steps are working before I put it in batch mode and high speed mode. So that's a good way to debug. If you've got a flow not working, Jmeter will show you the request and what the response came back and all the checks. So highly recommend using the GUI the first time just to check it out. And what the script does now is it simulates 4 kinds of shoppers. Some that we've all done online shopping, right? So some just you browse a site, or you browse a site and you throw stuff in the checkout cart and you just throw, you abandon the site, or you put stuff as a guest, you check out as a guest, or the most database intensive is if you log into the site as a known customer and then you check out as a registered customer. And you can control those percentages, and so if you want to shift the workload more to the database, you can increase the number of registered customers checking out or shift it back. And then you set up this ramp time. The ramp time then is how much time it will launch all the users. So we run with typically like 6 minutes or something as the launch time. All right, there were a couple of gotchas in there, and again, I won't go over that now, but there were some cache types, and we'll send you this deck. You had to do some editing to correct a couple of things in the Jmeter script to match up with some updates. I actually met the woman from Magento who coded up the install and this stuff so we're going to get that sorted out. I don't know if any of you have seen the Jmeter output, but the Jmeter is a nice tool. It produces a lot of good metrics. It will report the total number of transactions that have gone both in the interval and to date so far during the test, the transactions per second, the average, minimum. The minimum usually isn't very worthwhile because the Jmeter does a lot of initial transactions just to get set up, and of course those are very quick. And then there's a tweak here too. We'd go into the Jmeter ini file and has it report every 5 seconds instead of every 30, which is the default, which is another tweak. So here's a good little quick, are we doing on time? Oh, good. So here's the effect of the power. Remember you talked about how Power 8 has 8 threads per core. So this is the 2 This is 2 app servers on the Power box, the 2 6-core app servers. 6 times 8 is 48. So the operating system sees 48 processors. So both these are the 2 6 cores, and you see the 48 processors there. This is just an H-top, again, regular tools that you're used to using on x86, run fine on Power. Here's the 10-core PHP servers that are running on Haswell, on the Haswell system. So 2 times 10 is 20, so you see the 20 cores there on the Haswell system. I'm sure if you guys have all run NGINX, you've seen the dashboards here. This was a good kind of interesting. We ran with 13,400 users here in 6 minutes, and you can see that there's over 120,000 transactions flowed through this little setup. There's an average transaction time about 2.3 seconds of all the transactions. I'll talk about that in a minute. There's a little bit of error rate. I'm getting a class unknown error that Jmeter's throwing that every now and then. It does it with the Intel, so again, little tweaks. You got to sort of be aware of your test rig is some issues. Jmeter puts out some great metrics. So you put out a CSV file that you can suck into a spreadsheet, and we suck that into a spreadsheet and we subtract out all the non-user transactions. And what we use as a criteria is if 90% of the user transactions complete in less than 2 seconds, then the test passes. It's analogous to essentially website response time. If it's worse, if it's less than that, then we say the test didn't pass. You've oversaturated your server. So what's next? What we're going to look at, we want to do some more with our Mellanox. They've got both a 10 gigabit and a 40 gigabit adapter. They also support, on their adapter, support some Open vSwitch offload, so we want to work with that a little bit. Also, single root IO virtualization, another area we want to work in, database clusters, and I forgot to add SSL to the link. We want to do some work with NGINX and SSL. I have a little movie to show you quickly, but I want to make sure if you're a developer, if you haven't been to our IBM developer work site, Google it. It's a great resource for developers. There's all sorts of code samples out there. There's white papers, there's ideas, there's all the different technologies, Java, PHP. So it's a great place to go peruse and look through if you don't know about it. If you're interested about more about Power, the Power servers, again, Google IBM Redbooks. You put in Power in there. There's several hits, and the Redbooks there you can go in there, has all the architecture of the servers, the speeds and feeds, how they're structured, memory, adapters, good resource of information if you're curious about the actual physics of the adapters, of the boxes themselves, the servers. We do have a TurboLamp community out there. If you have any questions or you want a copy of this presentation, email us at tlamp@us.ibm, so turbolamp@us.ibm, and we can send you back a copy of this presentation. As far as what packages, if you've got some packages, you want to try something out on Power, then we've got a tool out there called OSPAT. You can put that package in, and we'll come back and tell you what versions of the distros support that package. We've got a free Power, if you also can Google Power PDP, Power Development Platform. And that's a free Power systems you can get in the IBM Cloud if you want to try out some functional evaluation of your applications. There's compilers up there. You can recompile and try it out, so that's available. If you're not sure about what package you want, we also have a category browsing. You can sort of look through the different categories of packages that would be available. All right, so thank you. Let me run, before you clap, let me run a movie here. Let me just show you and we can show you this at the demo pad too. Where's my movie here? There it is. Let's go to full screen. Okay, so what you're seeing here now is we've launched on the top 2 of the Power system, the 2 PHP servers running on the Power system. The bottom 2 are the 2 PHP servers running on the Haswell system. We're sending that same workload, about 8,000 users in 6 minutes, to both of the systems at the same time. And you can see on the bottom, the Haswell system, the Intel system is starting to get saturated. And as you know, once you get about 80, 90% utilization, the Haswells have to actually drop their clock rate so the chip doesn't overheat. Power does not have that problem. We run at full clock rate all the way through. So you'll see the x86 system is becoming saturated. And remember, the bottom is 2 10-core systems are on the bottom, 2 10-core systems, and the top is 2 6-core systems. So we're doing, with 6 cores, we're about 50% utilization, whereas the 2 20-core systems is just about saturated on the bottom. So, and then the top system actually costs less than the bottom system. So we've got a good performance advantage and a price advantage on that Haswell box. And hopefully by the time our next convention coming up a little towards the end of September, we should have some Broadwell numbers available for everyone too. All right, that's it. We're on time. And if there's any questions, I don't know if I'm sure you're going to have, but we're also in the PED, so come visit us at the PED if you've got any follow-up questions or want to talk some more.